Welcome to The Explainer. Today, we're diving into a genuinely revolutionary leap in 3D printing materials. If you've spent any time at all in the makerspace or doing industrial prototyping, you know the drill. The hardware, it's evolved at lightning speed. But the materials, well, they've been kind of stuck in the same surprisingly messy paradigms for years. But today, we're unpacking a brand new technological breakthrough that promises to flip the script entirely. We are talking about the dawn of solid-state resin. Let's get right into it.
Okay, let's just be totally honest with each other for a second. Are you absolutely tired of toxic liquid resin spills? Because anyone, and I mean anyone, who has ever operated a light-curing 3D printer knows this pain all too well. We universally despise the messy, sticky, goopy reality of traditional liquid resins. A single knocked-over bottle can literally ruin a workbench, destroy a print, and frankly, just ruin your whole afternoon. It's kind of the dark side of high-resolution 3D printing that we've all just had to accept. Until right now.
Because, liquid resin is a headache that goes way beyond just a simple spill. The source material outlines some seriously compounding hazards here. First off, we're dealing with high volatile organic compound, or VOC emissions. That's what gives you those pungent, irritating odors that basically force you to ventilate your workspace like a full-blown chemistry lab. Then, there's the whole logistical nightmare of it all. Liquid resins carry a massive risk of messy leaks during shipping. That makes transporting them hazardous and, of course, really costly, since they often have to be handled as dangerous goods. It's just a massive environmental and logistical hurdle at literally every step of the process.
Section 2. Meet solid-state resin, a paradigm shift in materials.
So, what exactly is this stuff? Well, we are finally leaving those messy liquids behind and entering a completely new era of material science. Solid-state light-curing resin is this incredibly innovative material that stays as a stable, non-flowing solid at room temperature, and it liquefies only when it's heated. Think about that for a second. It's totally solid sitting on your shelf, it's solid bouncing around in the back of a delivery truck, and it becomes a liquid only at the exact moment you need it for your print. It's almost like magic.
The contrast here is just night and day. On one hand, you have the toxic past, traditional liquid resin with all its messy leaks, high VOCs, harsh odors, and shipping hazards. On the other hand, you have the clean future, the new solid-state resin. Because it actually stays solid at room temperature, those monomer molecules are significantly suppressed from evaporating into the air. What does that mean for you? It means remarkably low odor and drastically reduced VOC emissions, giving you a much healthier workspace. Plus, no liquid means absolutely no leaks, which translates directly into safe, cheap, and totally worry-free transport.
Now, you might be wondering if this is going to overcomplicate your workflow. Actually, scratch that. It makes it incredibly simple. It's a completely plug-and-play process. Step 1, store it safely as a solid. No secondary containment tubs needed. Step 2, heat it up to easily liquefy it. And Step 3, print seamlessly. That is literally it, the whole shebang. It completely eliminates that anxiety of pouring, splashing, or overflowing your vats.
Section 3. Seamless printer compatibility. Upgrading your existing setup.
Now, I know what you're probably thinking. Great, do I need to go out and buy a whole new multi-$1,000 rig to use this? The answer is a definitive no. This material seamlessly integrates into the gear you already own. It works flawlessly with standard SLA and DLP light curing printers. And what's really cool is that the material design is so clever, it shows excellent universality across mainstream resin bases. Whether you're working with an acrylic base, a cyanoacrylic base, or a silicone-based resin, the mixing process is remarkably simple. You don't need to be a chemist or make any complex modifications to your existing resin formulas to make this work. It just blends effortlessly into what you're already doing.
Okay, this next part is a real game changer, highlighted in the source material. This stuff isn't just for vat polymerization printers. We're talking about a massive FDM breakthrough. Because the material is solid at room temp, it can actually be formed into flexible filaments. It maintains just the right amount of hardness to provide the driving force needed to run through standard FDM extruders and feeding mechanisms. Yeah, you heard that right. You can literally extrude it like standard plastic filament, but then enable light-curing cross-linking directly via FDM. You are basically bringing high-end light-curing capabilities right to your trusty traditional filament printer. No way, right?
Section 4. Smart and sustainable printing. The future is zero waste.
This material really elevates 3D printing into some true futuristic manufacturing territory. It features a thermal shape memory effect, meaning this resin isn't just a static piece of plastic once it's cured. It's essentially a smart material. Printed parts exhibit a significant heat-driven shape memory effect, They can autonomously recover their original shape when exposed to specific temperatures. This opens up entirely new horizons for smart applications. Think about customized wearable devices or precision medical tools, where the materials actually need to adapt and respond to their environment.
And if that wasn't enough, this also creates a completely sustainable ecosystem. The zero-waste workflow here is absolutely crucial. Think about how much liquid resin you usually wipe away with paper towels and just toss in the trash. It's a lot, right? Well, with solid-state resin, the uncross-linked, uncured material left on your print can be easily removed, whether mechanically, with a hot liquid, or a solvent. And here's the absolute kicker. You can take that unused material, directly remelt it, and cycle it right back into your very next print. It is 100% recyclable for continuous use. This drastically cuts down on material waste and firmly aligns 3D printing with sustainable, zero-waste practices.
Which brings us to our final point and a question for you to ponder. Are you ready to unlock the future of 3D printing? Today, we've explored this massive leap from hazardous, messy liquids to smart, clean, and endlessly recyclable solids. This solid-state, light-curing resin doesn't just fix the most annoying parts of 3D printing, it genuinely upgrades your existing hardware, introduces wild, smart thermal properties, and completely eliminates waste. It's a totally new paradigm for the industry. Thanks so much for joining me on this explainer, and I hope this leaves you as eager to get your hands on this incredible new material as I am. See you next time.